what does the first one say that I wrote down? It says, guessing the initial of a student's middle name. How many different ways would you guess the initial of a student's middle name? 26, right? It's going to start with one letter in the alphabet. I mean, I'm assuming it's a, our alphabet, A, B, C, D, E, F, G, right through X, Y, Z. So the sample space and actually I put a little set notation for you, but it would be what? A, B, C, D, X, Y, Z. And how many different possible outcomes could occur then? 26, right? It's going to start with one of those letters, right? So there's 26 different letters it could start with, so there's a number of possible outcomes. Equals 26, the 26 letters, okay? Make sense to everybody? Now let's look at the second one. The second one is we roll 2 dice. Not one, but we roll 2 dice. Now, when I roll 2 dice, I'm going to wind up with some number, because they both have 1, 2, 3, 4, 5, 6 dots. So the number I get is going to be 2 through 12, right? Everybody's got that, probably people have played the dice. But what are the 36 possible outcomes that can occur when I roll 2 dice? And there are 36. Jump right into this conversation that I'm having with myself. Huh? Well, all right, we're going to do this simultaneously. One die, I'm not going to roll 2 dice in one hand. Garrett gets one, and Xavier gets one, okay? Okay, so now wait a minute, before you start, okay, we'll put, Garrett will go across the top. 1, 2, 3, 4, 5, 6. And Sehu will go here. Okay, 1, 2, 3, 4, 5, 6. Okay, so let's roll them a couple times, okay? Tell me what to do. Yeah, you stay on your own goddamn desk, will you?
I got 4.
I got 5.
Okay, so 5, 4. What did you get?
2.
6.
6, 2. 6, 2. Okay, roll them again. Okay, yours first.
1.
1,
4.
1, 4. 1, 4. Roll them again.
Your first coordinates.
3.
What?
Your first coordinate, the 5, 4. You got
Oh.
it at 5, 5.
Thank you very much. Come on, you guys get a 5, 5 for me then. What did you get, David?
3.
3,
6.
3, 6. 3, 6. Okay, we're going to do 2 more. I think you get the idea here. Right?
6.
5.
6, 5? 6, 5. 6, 5, one more.
4.
2.
4, 2. 4, 2. Okay, so we could do this for a while. But how many possibilities exist?
36.
36, right? And so if we filled it all in, you know, it'd be 1, 1, 1, 2, 1, 3, 1, 5, 1, 6. And go ahead and fill it in. I'll take the time up here because I'm going to use it later also. 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 4, 1, 4, 3, 4, 4, 4, 5, 4, 6, 5, 1, 6, 1, 2, 5, 3, 5, 5, 5, 6. Okay, so here's the question, is 2, 5 the same as 5-2?
Oh.
It's not, is it? There's 36 different outcomes that can occur. And I know a lot of times we do this, people will say, oh, wait a minute, there's 5-2 and 2-5 are the same, okay? You can't kind of count them separately, right? But then the other question is why isn't there 2 4-4s? So where would I put it? Say you got a 4, Garrett got a 4. I mean, where else am I gonna put it, right? I mean, it's a 4-4. I can't differentiate between 4-4 and 4-4. There's one of them. Does that make sense to everybody? So how many people had a discussion that said 5-2 and 2-5, they're the same? Okay. Well, I heard Jordan refereeing the discussion, right? All right, so there's 36 different outcomes here, okay? So 36 different outcomes, okay? Don't use your intuition totally. Let's look at the last one, okay? Tossing 3 coins, okay? What happens if I toss 3 coins? What are the possibilities, okay, in terms of getting heads and tails? Garrett?
8 different possibilities.
8 different possibilities, right? How did you come up with 8 different possibilities?
I just wrote out 3 heads, 2 heads, and a tail, in order of
Okay.
each.
So
Coin
wh-
1, coin 2, coin 3.
Yeah, one way to do that is to say, okay, first flip, what happens? Right? Second flip. Which is what you did, wrote it all out. And then I got a third flip. And what can happen? 2 things, right? Now, the path that Garrett wrote out, if I follow this top path, first flip was head, head, head. So this yields what? This outcome of H, H, H. This outcome here is yielded H, H, T, H, T, H, H, T, 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 H, H, T, H, T, 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 H, and T, T, T. Everybody see that? Well, that's all, I mean, one of those 8 things is going to happen. There's no question in my mind that that's it. We got them all covered, right? There's nothing else that can happen. Now, this is called a tree diagram, and all I did is say, well, there's 2 things that can happen on the first flip, there's 2 that can happen on the second, and there's 2 that can happen on the third. So this is a kind of a good setup for something that's called the fundamental rule of counting, or the fundamental principle of counting. And really, if I look at those 8 outcomes, 1, 2, 3, 4, 5, 6, 7, 8, they are represented by what? 2 things could happen on the first, 2 things can happen on the second, and 2 on the third. Now, how did I get 8 out of the 2 times 2 times 2? Well, because I went 2 here, and that spawned 2 more each, and that spawned 2 more each. So that times that is telling me how many outcomes can occur. That makes sense? Questions? So this idea of counting, sometimes counting results and figuring out how many things can happen, how many outcomes in the sample space, sometimes gets a little difficult, but there is this idea, and I think I put it on your worksheet, called the fundamental